Morning guys, let's move on towards the next problem. This problem is little different than the previous problem whatever we have solved. So let's see what the problem says. A hollow propeller shaft means same shaft is to transmit 3750 kilowatt at 240 rpm, comma if the internal dia is 0.8 times the external dia, and if the maximum shear stress is developed is to be limited to 160 newton per mm square, determine the size of the shaft. So basically you see what all things are given to you and what you need to find out. They have said it's the hollow propeller, means it will have an internal dia and external dia. It will be something like this, the cross section. Okay, and it is to transmit 3750 kilowatt power at 240 rpm. So from power and 240 rpm we can calculate t, right? So 2 pi nt by 60, from there you get power p and you can calculate the t. And they have said internal dia is 0.8 times the external, that is di is equal to 0.8 times do. Will make di and do outer and internal. Okay, and the maximum shear stress to be developed is 160. So we can use only half the equation, that is T by J equals G Q by R. So from these two things we can find out the dia of the, or they have told to determine the size of the shaft, that's nothing but internal and external dia. So without wasting a time, let's move on towards the solution. So guys, you can write today's date. Today's date is 16, is it? Yes, 16 10 20. So given power P is equal to 3570 kilowatt, that's nothing but 3750 into 10 to the power of 6 Newton mm per second. So this explained in the first class of torsion itself. Then N is given as 240 number of rotations or revolutions per minute. Q is equal to, it is clearly said, should not exceed 160 Newton per mm square, and they have said let di be the internal dia. Internal dia is equal to 0.8 times the external dia. Let di and do be internal and external dia respectively. Okay, so now we can go for calculation of torque first. Calculation of torque or torsion T. We know that power P is equal to 2 pi nt by 60. So n is known to us, P is known to us. So let's substitute the value of P, 3750 into 10 to the power of 6 equal to 2 into pi into n is also known to us, 240. T we need to calculate divided by 60. So from this you get T 149,207 into 10 to the power of 6. So this is T you get. So once getting T, we can calculate the dia. Calculation of dia of shaft. So we know that equation T by J equals Q by R. G theta we cannot use because G value or theta value or length is not given to us. So we know these two things. So now what about J? J in actually is pi d raised to 4 by 32, but here in this case it's pi do raised to 4 minus di raised to 4 divided by 32, or pi d naught raised to do raised to 4 by 32 minus pi di raised to 4 by 32. I have taken pi by 332 outside common. Okay, and r is equal to, it's d naught by 2, because you can draw or else this sketch d internal d external. So radius from the center r is always d by 2, d naught outer diameter by 2, so it's d naught by 2. So now let's substitute all the values. 19.207 into 10 to the power of 6 divided by this, so that is pi d naught raised to 4 minus d1 raised to di raised to 4 by 32 equals 160 is given q, r is d naught by 2. Now there are two different unknowns in this single equation, so we cannot find out it. So we have from this di equals 0.8 times d naught, so I can replace di as d 0.8 times d naught. So my equation will turn out to be 32. I'll take it up with this 32. I'll take it up pi d naught raised to 4 minus 0.8 d naught, so in the place of di raised to 4 equals 160 into 2 by d naught. So now elaborating this, 207 into 10 to the power of 6 into 32 divided by pi into d naught raised to 4 minus, so 0.8 raised to 4, d naught raised to 4, 0.8 raised to 4 is 0.494096, d naught raised to 4. Okay, again it's 320 by d naught. So now we'll minus of this d naught from each other because both are same, divided by pi 1 minus 0 point something times of d naught, will get it as 0.5904 d naught raised to 4. It's 320 by 2, sorry, 320 by d naught. So now d naught will take on one side, remaining terms will bring it on other side. So this about term we'll do it like this. Okay, 149.207 into 10 to the power of 6 into 32 divided by pi 0.5904 into 320 is equal to, 320 is brought here, this I'll take it on other side, d naught raised to 4 divided by d naught. Okay, so now here 1 d naught cube and this total d cancels. So therefore I can write it as d naught cube is equal to, if I solve that left hand side part, I will get 0.8.044 into 10 to the power of 6 d naught is equal to 8.44 into 10 to the power of 6 raised to 1 by 3, because d cube. So therefore d naught is equal to 200.36 mm outer dia. So inner dia di is equal to 0.8 times of d naught, so 0.8 times of 200.36, so that equals 160.29 mm. So this is di and this is d naught. So therefore provide shaft or hollow shaft of internal dia 169.29 mm, you can write the same, okay, and external dia 200.36 mm. So this completes your another kind of problem. So you can write down this, and if you have any doubt you can call me back so that I can help you out. Thank you.